Hello and welcome back, Croeso. This is lesson 2 for year 10 physics, electrical circuits. Quick recap on what you learnt in lesson 1. So this is your booklet from lesson 1. You learnt these different symbols for electrical components and started to practice the skill of drawing circuit diagrams, and we very briefly touched on Ohm's law circuit using ammeters to measure current and voltmeters to measure voltage, and briefly looked at the difference between series and parallel circuits. Going to the spec and the learning outcomes required for the course. If we look at that here, we've highlighted what you learnt in lesson 1 above. So today we are going to be learning, I will highlight in green today, lesson 2, pages 7 to 12 in your booklets. We're going to be learning about series circuits in which the current is the same throughout the circuit and voltages that add up to the supply voltage. Therefore, we concentrating today on series circuits. Parallel circuits is something we're going to go on to later in lesson 3. Okay. So, back to your booklets. Please put today's date and lesson 2 at the top of page 7 and of course underline. You see 3 words at the top. We're going to be using these words and terms a lot during this topic. In today's lesson, we're going to start to use and gain an understanding, more importantly, of what these terms mean. If we look at them one by one, firstly current. I think this is the best place to start because it really explains what electricity is. Electricity, and I'm going to write this down in large capital letters because this is the essence of electricity. Electricity is a flow of electrons. And just in case you've forgotten what electrons are negative charges that you find orbiting the nucleus of an atom. So remember, in the middle of an atom you have a positive charge called a proton, a neutral charge called a neutron, and orbiting around the outside you have these electrons. So that's a very basic atom there, isn't it? One proton, one electron, that would be a hydrogen atom. But in much larger atoms and metallic atoms such as copper that are good conductors, what you've got are these free electrons further out in the outer shells that are, as I said, free electrons that can move away from the restraints of the atom itself and the nucleus, and they are what carry the charge, and that's what electricity is. Look at the word electricity. You can see how it relates to electron. It's a flow of electrons. And if you think of water flowing around a system or a central heating system, it has to be moved around. You need energy to move it around in the first place. It needs to be pushed. So a potential difference, another word we use for potential difference is voltage. Voltage provides a push. It moves the electrons around. It provides the energy. And resistance resists the flow of the electrons. So voltage provides a push to the electrons. And resistance resists the flow. Watch this now. A large voltage, let's try again. A large voltage means you get a large current. So if the voltage goes up, the current goes up. With resistance, if resistance goes up, the current goes down. And that's what this diagram underneath here, where these three cartoon characters are trying to show. The only difference is that you'll notice they've got the unit there for current, amps. The unit there for resistance, we haven't met that yet, which is ohms. And by the way, the symbol we use for amps is capital A. The symbol we use for resistance is a Greek letter, omega. And the symbol we use, this is voltage. The symbol we use for voltage is just capital V. So look what's happening. We've got this poor electron here. Let's call him Mr. Current. He's trying to be pushed by this angry looking Mr. Voltage. Look, he's trying to kick him along the wire. And you've got Mr. Resistance up here trying to stop him moving. And that's really what electricity is. It's difficult to understand sometimes because you can't see it. It's abstract. So what we have to do in science is use an example, an analogy to help us understand. Jumping into the school website, there's a useful piece of software called Focus e-Learning, and we just selected the Key Stage 3 physics from there, within which there's a useful modelling of an electrical circuit. So electric circuits, as we know, consist of a loop of wire, something to provide the push for the electrons, a battery, and something that resists it, in this case a bulb, and something there like to switch the circuit on and off. Underneath, I particularly like the way in which they model the current, where you can think of electricity similar to a flow of water going around a water system. The pump for the water providing the energy, or the push on the water, similar to a battery providing a push on the electrons in the circuit. The water wheel here slows down the flow of the water. It resists the water just as the bulb does here. Now the job of the bulb, of course, is to convert electrical energy into light energy. The job of the water here is to turn the movement energy of the water and the movement of the water wheel. So it's just a transfer of energy. But watch what happens if we double the voltage. The bulb gets brighter. It's the same as doubling the number of pumps. So you get bigger push on the electrons. You've got a larger current flow because you've got more electrons flowing around the circuit, which we can think of as more water flowing around. The water wheel moves faster. Just as if we go back to the original model and we don't double the voltage, but we double the resistance. Now we can do that by putting 2 bulbs in. And with the water, we've put 2 water wheels in. So it slows down the current. Look at voltage. The idea here is that these little red marbles are modelling the electrons. You can see on the right hand side here, we've got that same situation where we've got the energy being input by the cells, a resistor this time, resisting or reducing the size of the current. And if we click on these different labels, it says above, the motor converts chemical energy in the fuel to kinetic energy and turns a conveyor belt. 2, the conveyor belt increases the potential energy of the balls. So we think of that as in terms of electrical circuits, the battery gives the electrons more electrical energy to move around the circuit. And part 3 here, this is where the energy is lost. As the balls roll down the slope, the potential energy is converted to kinetic energy. So that would happen here in the resistor part of the circuit. Let's apply that now back in our booklet. Make a few quick notes on current first of all. What is current? It's the rate of flow of electrons. So that means how many electrons flow through a wire per second or within a given amount of time. It's the rate of flow. Now, next we are going to learn 5 different rules, and you have to learn how to apply these rules to different circuits. For today, we are going to learn rule 1. That's for a series circuit, and rule 2 also for a series circuit. The difference between the two is, if you look at rule 2, it's to do with voltages in a series circuit, and for rule 1, it's to do with current in a series circuit. In our next lesson, we'll be learning the other rules. So for today, it's rule 1 and rule 2. I'll let you read this in your own time. Just pause the video. I'm going to do a few examples myself and then leave you do some in your own time. Look at this first one. First question. Question 1. Label up inside the 2 blank circles as A1 and A2. What do these components measure and give their units? Always split, like there's 2 marks to this question. What do they measure and give units? Answer so that you hit both those marks. They measure current and their units are amps. they could have asked, what are these circles? Well, these circles, let's just label them first of all. A1 and A2. They both, of course, are meters. I'll just label one of them for now, ammeter. Okay, there's our ammeter. And go back to the question. Finish question 1 then. On to question 2, that's just a bit of retrieval practice from previous lesson. What you need to do is look back and find out what that represents. I've asterisked that in red for you to do. Underneath is a practical. It says set up a circuit above and record the ammeter readings for A1 and A2. You can see there it's a circuit with power supply, 2 ammeters and a bulb. We'll simulate that using the piece of software we looked at earlier, using the Focus on Science software. What you've got here, you can see 2 ammeters and a bulb and a power supply, in this case 1 cell. I'm going to teach you now the 2 rules. So the first rule is that the current in a series circuit, this is a series circuit because it has only 1 loop. That's a parallel circuit. Series, parallel, parallel, series. A parallel circuit has got more than 1 loop, or what we call a junction. Here's a junction. So the electricity can flow one of 2 ways. We're going to be learning about parallel circuits in the next lesson. In this lesson, we're learning about series circuits. That's a series circuit. We'll start off with a single bulb, 2 ammeters. The rule you need to learn, rule 1, is that the current flowing through a series circuit is the same at all points. 0.1 amps there, 0.1 amps there. There'll be 0.1 amps everywhere around the circuit, including going through the bulb. If we increase the number of batteries, we're increasing the voltage, therefore we're increasing the current flowing around the circuit. The second rule is what happens to voltages in a series circuit. Well, the voltage of the supply, in this case 3 volts, equals the voltage across the components in the circuit. In this case we only have 1 component, 1 bulb, we have 3 volts across that. Let's see what happens if we have 2 bulbs. 2 bulbs, we'll put in the ammeters, we'll switch on, we'll put on the voltmeter, switch on. Okay, what you notice here is that the voltage across the 2 bulbs add up to the supply voltage of 1.5 volts. The current will be 0.5 amps all the way around the circuit. The voltmeters themselves, they're not part of the circuit. No current actually flows up there. All they are doing is measuring the voltage across the bulbs. Here, and that's measuring the voltage across the power supply, in this case the cell. If we increased the number of batteries, 3 volts, 1.5 volts across each, you can see the current increases, increase again, 4.5 split 2 ways. Notice that every cell is 1.5 volts. 4 batteries, 6 volts, split 3 volts, 3 volts. So 6 divided by 2, and bulb blown. So you can't have more than a certain voltage across a bulb before they blow. Okay, so that can take 3 volts, but it can't take 3.75. Those are the 2 rules. Let's apply. This is your booklet. Set up the circuit above and record the ammeter readings for both A1 and A2. Let's just add in the ammeter readings. So we'll add in 0.1 amps, 0.1 amps. Results. Both ammeters read the same current. So those are the results. We could add to this and say this happens because the current is the same and it's all the way around the series circuit. This happens because each point in a series circuit. So let's be clear on what that is. That is actually rule 1. Oh, unusual choice of pen. Let's change the colour. Rule 1. That's the first thing you've got to remember. Question 3. It says, in this circuit, the same number of electrons pass through each component every second. So we can say the current anywhere in a series circuit is the same. Question 4 is one that I would like you to do. So you need to work out the current for A1 and A3. Big clue there. Question 5, I won't write it down, but I'll give you a verbal answer to help you. It says, or asks, where might you have seen a circuit like this, and explain why this circuit is not used in airport runway lights. When it's saying or asking, when you've seen a circuit like this, it's referring to this circuit, a series circuit. So there's 2 parts to it. Again, explain why this circuit is not used in an airport is the second part. The first part, where have you seen a circuit like this? Mostly circuits are parallel circuits, because in a series circuit, if one bulb were to break, let's say if that bulb there were to break or blow, that would prevent electricity flowing around the rest of the circuit. So that would mean that bulb wouldn't work and that bulb wouldn't work. The other problem with series circuits is, as I showed you in the simulation a few moments ago, if we wanted to have, if each bulb needs 4 volts across it, for example, to be at the level of brightness we desire, then you would have to have 4 volts there, 4 volts there, and you'd have to have a really high power supply in order to deliver that. That's not the case with parallel circuits. So in short, there's 2 reasons that why you wouldn't use a series circuit in airport runway lights. Number 1, it would be dangerous because if one bulb broke, all the bulbs, all the bulbs would go out, and therefore highly dangerous. Number 2, the bulbs wouldn't be as bright as if they were wired in parallel. The first part of the question, where might you see a circuit like this? One of the few places where you'd see a series circuit would be Christmas tree lights. And that's why sometimes you'll notice when one bulb goes in Christmas tree lights or Christmas lights, all the bulbs go off. Can be very annoying. If you've seen the film Deck the Halls, there's a case there where the father's trying to identify which of 1,000 bulbs is blown for his Christmas light to come back on. Therefore, finish question 4 and 5. Moving on to rule 2. Just covered it in the simulation. Rule 2 deals with the voltages across components in a series circuit. First thing you need to do, I've made a start, is to add in wires to connect the 4 voltmeters, label V1, V2, V3, V4, to the circuit. Remember, voltmeters are always measured in parallel, so they go across the component for which they're measuring the voltage of. Okay, I'll let you finish off V2. Question 6. We've just started, that's adding the wires. And in the box, the important part here, the PD. Remember, the PD means the same as voltage. The PD supplied by the DC supply in a series circuit. Okay, this is the DC supply. Don't worry about what DC, just direct current. We'll be learning more about that later in this booklet. The PD supplied by the DC supply in the series circuit is shared between the components in the circuit. So you can see V1, and that's the voltage across the DC supply, so supply voltage. That is then shared between the 3 bulbs measured by V2, V3 and V4. Page 11, what we've got here is that same circuit. This time we've got an 18 volt supply, and that 18 volt is going to be split between V2, V3 and V4. If the bulbs are identical, which they are, and I've put a little annotation here to explain the significance of that one word, identical. Identical obviously means the same. So if they're identical bulbs, they would split the voltage equally amongst themselves. So that 18 volts would be split equally 3 ways. 18 divided by 3 is 6 volts. So that's question 7 done for you. Question 8 is asking the same question, but this time the supply voltage is 24 volts. Therefore, you've got to split that 3 ways. Question 9, again for you to do. This is asking what would happen if the voltage was kept at 24 volts and we added in another bulb, an identical bulb. What would be the values then? Well, I'll make a start for you, 24 volts, because that's the supply voltage, and then you'd have to split that 24 volts, not 3 ways, but 4 ways. What would happen to the bulb brightness by adding more and more bulbs? Look back at the simulation, you should be able to answer that. And then finally, before we finish lesson 2, question 10, not all bulbs are identical. Remember what identical means. If they're identical, they share the voltage equally. If they're not identical, they don't. Not all bulbs are identical. If the power pack supplied a voltage of 12 volts and the readings of V2 and V4 was 3.7 volts, what would be the reading of V3? Therefore, what we've got to do is apply that rule 2 for voltages in a series circuit. And the rule is the voltage across the power supply equals the sum of the voltages across the components. Now, in the circuit that's being referred to, there are 3 bulbs measured by V2, V3 and V4. If you add those 3 bulbs together, they equal the supply voltage V1. The supply voltage is 12 volts. V2 is 3.7, so we substitute 3.7 and it's 3.7 for V4. Therefore, the physics is complete at that point. It's now using your mathematical skills, algebra, to rearrange that equation so that V3 moves to the left hand side, so we're over here, and what you have to do then is take away 3.7 from 12 and do that twice, work out the answer for V3. Quick recap before we finish. You have learnt today then 2 rules for series circuits. And there you see them. 1 for current flowing through a series circuit, 2 voltages in a series circuit. Please make sure you complete the assessments within Study Zone and look at the video within lesson 2, and make sure if you don't understand first time, you press pause, rewind and listen again. Okay, see you next time. Bye.